Hey guys, welcome back to another episode of Welding with Mr. Stepanek. For today's lesson, we're going to be talking about steel to metal arc welding in the vertical position. Okay, now this is much more difficult than welding in a flat, in a horizontal, and even in the overhead position. Okay, there's a certain way that you have to do things in order to have a nice weld, and we're going to go over a few of those things. Couple of objectives that we have here. We're going to describe the procedure for downhill welding. Now we do a minimum amount of downhill welding, and I'll explain that here in just a few minutes. We're going to explain some common techniques used for the uphill welding process and some low hydrogen electrode welding techniques. If you were to weld in the downhill position, okay, now number one, you're working against gravity. So if you are welding downhill, you want to make sure that that rod is pointing up toward the beginning of your weld. So that's what's called a drag travel angle. Okay, so this drag travel angle you want to have between 15 and 30 degrees. Now, the main reason you want this rod angle at such a large angle pushing up toward the top of the weld is because depending on the rod that you're using, you're working against gravity. So that rod is actually going to follow you going down that weld, and you're going to get the bead going to start to catch up to you depending on the rod that you're working with. So if you have a straight on weld or even a weld pointing down, that rod's going to pass you up, and you're going to have a not so good of a weld. Okay. Um, the next thing is downhill welding is meant for, you could essentially say, material that is 1/4 of an inch thick or thinner. Okay, downhill welding doesn't give you a lot of penetration. Okay, because you're penetrating back into that liquefied material. Okay, so downhill welding, 1/4 of an inch material or less. So thinner gauge material is essentially what you want to use welding downhill. Now, in uphill welding, you want to position the electrode holder until the electrode forms a travel angle of 10 to 15 degrees pointing away from the direction of welding. Okay. Now, number one, I like to say about a 5-degree angle pushing up. One of the reasons is because you guys are learning how to weld right now. And if you start on a 10 to 15-degree angle, by the time you get to the top of your weld, what's happened is you've now went from a 10 or 15-degree angle to a 25 or a 30-degree angle. So if you start at about a 5 or so degree angle, naturally you're going to twist your wrist up, especially as a beginner. So if you start at a 5-degree angle, by the time you get to the top, you're going to be at about a 15-degree travel angle. Now, uphill welding, unlike downhill welding, uses what's called a pushing technique. Okay, downhill uses a drag travel angle. Uphill uses a push travel angle. So there's a difference between both of those. Uphill is going to give you more penetration into your base material. And uphill is also designed for material that is 1/4 of an inch thick or thicker. So everything on the thicker side of the weld. The width of the bead can be controlled by using a weaving motion, such as a figure 8, rotary, crescent, Z-weave, or box weave. Now, as a beginner, you guys are going to be running stringers, but when we get to our weaving motions, a couple of the easier ones is going to be like a U motion and probably the Z weave. Okay, I wouldn't recommend trying the rotary or the figure 8 till you get a little bit more experience in with you. It's a lot more manipulation. What comes with manipulation is some undercut. So you don't want to have undercut. So you want to try and minimize the rod manipulation that you're having to prevent that undercut on those sides as well. Couple of points to remember here. Downhill is used on light gauge up to 3/16. So 1/4 of an inch or less using downhill welding technique. 1/4 inch or above, you're going to use the uphill welding technique. Downhill welding is commonly used on metal 1/4 inch, uphill welding is commonly used on material 1/4 inch thick or greater because it produces deeper penetration than the downhill welding process. Weaving motion is commonly used to fill wide joints. Now, depending on the welding procedure, well, first off, you shouldn't do any type of weaving motion in a flat or horizontal position. Weaving is essentially designed for the vertical position. Now, it can be done in other positions, but depending on the welding procedure and the code that you're welding to, you might not be able to do that. Typically, your weld beads is going to be about 5/16 to 3/8 of an inch wide max. If you're welding in the vertical position, you can do a weave motion, and usually, once again, depending on the procedure, that weld, even in the weaving motion, is only going to be a maximum of 1 inch wide.